So this is a video about how to make orbital diagrams. When we make an orbital diagram, the first thing that we need to do is determine how many electrons an element has and their electron configuration. So we're going to start with helium. Helium has 2 electrons. The little E minus is a shorthand for electrons. And of course its electron configuration is 1s2. So when we draw the orbital diagrams, we draw the orbitals first, represented by these little brackets. The brackets are an orbital. Then you fill in the electrons. Each electron is represented by an arrow. In an orbital, we show one electron arrow pointing up, the other pointing down. This represents that they each have opposite spin. And then I'm just going to label that 1s to show that that is the 1s orbital. So that's a pretty simple one. Let's try one that has a little bit more to it, like neon. Neon has 10 electrons. And neon's electron configuration is 1s2, 2s2, 2p6. To make neon's orbital diagram, start off the same way. Draw the orbital, the brackets for 1s. I would add those 2 electrons. Then I like to separate the different sublevels by drawing just a vertical line to show that now I'm drawing orbitals for a different sublevel. This is 2s. 2s also fits only 2 electrons, so again we would draw 2 in that orbital diagram. Another vertical line because we're going to another sublevel, 2p6. Now, I suggest when you draw the orbitals in a sublevel where there's more than one orbital, that you draw all of the orbitals first to show that they all exist, but that you just haven't filled them yet. And this is, again, 2p. Since neon has 6 electrons, you fill, just like the atomic hotel, you fill 1 electron at a time in each orbital. So there's my first 3. Notice that they're all pointing upwards to show that they all have the same spin. And then I go back and I would fill electrons 4, 5, and 6. And I would just get in the habit of doing that because then you won't make mistakes like putting 2 in one orbital and 0 in the other 2 orbitals, which would be incorrect. So that would be for one a little bit more complicated. Let's do one more. We're going to do oxygen, which has 8 electrons. Oxygen's electron configuration, is 1s2, 2s2, 2p4. So we have 2 electrons in 1s. We have 2 electrons in 2s. Then we get to 2p. Again, I'm going to draw all 3 of the orbitals first. And I have 4 electrons. So this is where it gets important to make sure you only do 1 in each first, like that. And then electron number 4 goes there. And I'm done. I'm going to leave the other 2 empty with only 1 electron in each orbital. A couple other things that are common questions or things that people ask. Do you have to write out the electron configuration each time? No. I mean, if I asked you to do it on a test, you would do it, but you don't necessarily have to do it. If you get it and you know where they should go without writing it out, great, go ahead and go for it. If you're just beginning, sometimes people like to write out the electron configuration first because it helps them not make mistakes about where they put the electrons in the orbitals when they draw this orbital diagram, but it's up to you. Another question that gets asked is, what about a D sublevel? What does that look like? So since D sublevels can fit 10 electrons and they have 5 orbitals, a D sublevel like 3D or 4D should have 5 orbitals, and you would follow the same process as for the P's, except that you would put 1 electron first in each of the 5 orbitals, and then you would go back and fill electrons 6, 7, 8, 9, and 10 after that.